Okay, to answer question 22 from the Advanced Algebra 2 homework, what we're going to need to do is use the random number generator in our calculator, which I'll show you how to do. Because the question says, suppose the experimental probability is 1/3 that a carton of eggs contains at least one broken egg. Use a simulation of 20 trials to find the experimental probability that 3 cartons selected at random contain only unbroken eggs. Now it says, hint, use any 3 digits to represent cartons with broken eggs and 6 other digits to represent cartons with unbroken eggs. Now it says to discard the 10th digit. So one way of doing this, let's let the numbers 3, 6, and 7 represent cartons with broken eggs. Okay, let's let 0, 1, 2, 4, 5, and 8, 1, 2, 3, 4, 5, 6 represent unbroken cartons, or cartons with no broken eggs. Wow, having a hard time here. Okay, so now we're going to bring up our calculator. We're going to go to math. We're going to go over to probability. We're going to select rand. And this is a random number generator. Now, if we take a look here, our first 3 digits, 1, 4, and 6. Now, they don't contain the digit we discarded. So we can take these as being a random, I guess, generated sample of 3 numbers. So 1, 4, and 6. Okay, that one's broken. So if we have here a tally, well, the first 3 broken, 1, unbroken is 0. Okay, so we had 1, 4, and 6. Then we have 6, 8, and 7. Now again, that has 2 cartons with a broken egg, so that would be broken. Okay, then it says 1, 4, 6, 6, 8, 7, then 8, 2, 9. We're going to discard that digit because we didn't use it, so we have 8, 2, 2, those are unbroken, so unbroken here. Run this again, we just hit enter. Okay, we have 5, 1, 4. 5, 1, and 4, that would be unbroken. 7, 0, 1, 7 is broken. So 7, 0, 1 contains a broken. Toss out the 5, 5, 0, 5, that would be unbroken. So right now, after 6 trials, we are at 3 to 3. So we're going to run them again. Okay, looking here, we have 4, 0, and 5. That would be unbroken. We have 8, 0, and 6. We've got to throw the 9 out. 8, 0, and 6. 6 contains a broken, so we're even again. And then we have 4, 1, and 8. 4, 1, and 8 is unbroken. So we're now up to 9 trials. Run this again. 7, 3, 3. 7, 3, 3. Wow, every carton there contains a broken egg. Here, 8, 1, 2. 8, 1, and 2. That would be unbroken. Here we have 3, 1, 1. 3, 1, 1 contains a broken, so we're back to 6. 6 now, 3, 1, 1. We have that 2 there. Let's see, 2, 0, 4. 2, 0, 4. Unbroken. Okay, 2, 0, 4. So now we're back to 3, 9, 9. 3, 9, 9 contains a broken. 1, 9, 8. Okay, we've got to get rid of the 8. I mean the 9. Sorry, the 3, 9, 9. We had to get rid of that 9. So it would have been 3, 1, 8, still containing a broken egg. So now we're back here to 7, 5. 7, 5, 3 contains a broken. 3, 9, 3 again contains a broken. I guess we would have thrown out that 3, that 9, so it would have been 3, 3, 6. So now we're here at 2, 5, 2, unbroken. 5, gotta toss out those 9, so it'd be 5, 5, 4 would be unbroken. Then we're here at 6, 6, 3, that would be another broken. And then 4, 1, 1, that would be unbroken. So theoretically, only 1 out of every 3 cartons contains a broken egg, but according to our trial, it's actually 1 out of every 2 contains a broken egg, and that just illustrates the point that experimental probability is not always equal to the theoretical probability. And that's how you use a random number generator calculator to represent random trials. And that's how you finish question 22 from the homework.